Every cybersecurity assessment begins here, the reconnaissance phase. Before you can test a system's defenses, you have to map the network landscape, scan your target, and enumerate its hidden directories. By following this specific three-step workflow, you will build a comprehensive, actionable intelligence profile of any target machine you assess. But before you run a single command, there is a hard rule. You must have explicit, documented permission to scan a network. That legal authorization is the definitive boundary line. It is the only thing that separates a professional ethical hacker from a malicious threat actor. Let's start with a typical internal network assessment. You are plugged into the local environment, but the device landscape is completely unknown. We use a tool called Netdiscover. It relies on Address Resolution Protocol, or ARP. Netdiscover broadcasts ARP queries across the subnet, asking active hosts to identify themselves. As devices reply, Netdiscover matches their IP addresses with physical MAC addresses. To execute this scan across a standard local subnet, we run the command netdiscover-r followed by our target range, like 192.168.1.0/24. This terminal output shows the results, a list of active devices on the network. From this list, we select one specific IP address to serve as our primary target for the rest of the assessment. Keep in mind, this tool has a physical limitation. Because it relies exclusively on ARP, it cannot route traffic past the router to scan outside of your immediate local network. This initial mapping phase takes a blind environment and turns it into a structured grid of tangible targets, ready for direct probing. Now that we have our target IP, we need to analyze it using Nmap, the industry standard tool for port scanning. We will run a comprehensive scan by typing Nmap-A followed directly by that specific IP address we found with Netdiscover. The -A flag runs an aggressive scan. It actively probes the target to uncover open ports, determine exact software versions, and fingerprint the operating system. Looking at the completed output, we see a critical piece of information. Port 80 is open, indicating a web server is running. Comprehensive scans like this generate a massive amount of network noise, which will easily trigger intrusion detection systems or firewalls. If you require stealth to avoid those alarms, you can use TCP/SYN scans instead. These quick scans determine a port state without completing a full, easily logged connection handshake. You can also add the -PN flag. This instructs Nmap to skip the initial ping, allowing you to bypass firewalls blocking standard requests. This scanning phase takes a generic network address and turns it into a detailed architectural blueprint, revealing the exact software doors available for exploitation. Since port 80 is open, our objective is to explore the web server's underlying file structure using a command line tool called Dirb. Dirb relies on directory brute forcing. It runs an automated dictionary attack, rapidly guessing folder names to uncover hidden resources. You start it by typing Dirb, the target URL, and the path to your word list, which fuels the automated guessing process. During real-time execution, you watch the output for exposed paths. The tool has successfully located an admin panel and a backups folder. Beside those paths, you'll see an HTTP status code of 200 OK. That code confirms the hidden directory genuinely exists on the server and is currently accessible. Unearthing these hidden web resources exposes a system's soft underbelly. It reveals unintentionally exposed sensitive data and misconfigurations that remain completely invisible to standard web users. We started with zero knowledge of this environment. Now we have a fully mapped network, an accurately fingerprinted target, and a clear list of exposed web directories. The immediate next step for any ethical hacker is the meticulous documentation of this newly acquired intelligence profile. Every open port and accessible folder must be recorded. Cybersecurity defenders rely entirely on this foundational data to drive vulnerability management. They use these exact findings to identify outdated services and apply the necessary patches before they can be exploited. Executing responsible, authorized reconnaissance is the crucial first line of defense in securing networks against the tactics of malicious adversaries.